Hi, I'm going to walk you through this problem, area between two concentric circles. Let me get my tools ready. Alright, so when you're working on this problem, area between two concentric circles, what I want you to realize is concentric, con means with, centric means center. These are two circles with the same center, right? See, this is the center. It's the center of this circle and of this circle. So a ring-shaped region is shown below. The inner radius, remember radius is half of the circle, is 12 feet. You see that right here. So this is 12 feet. The width of the ring is 5 feet. So if this width of the ring is 5 feet, if it's 5 here, it's still 5 here. So if this is 5, if this is 5, then that means this whole thing, 12 plus 5, is 17, right? So this width is 12, and this whole width, this radius of the larger circle, is actually 17. So now what we're going to do is we're going to find the area of the shaded region and use 3.14 for pi. Don't round your answer. So we're finding the area, which means the inside. So what we need to do is we need to conceptualize this, right? So the ring, the shaded region, is really like this whole big circle. Take away this small circle. So that's what we're actually going to do. I like to write it out first. So let's write what we're actually doing here. Let's conceptualize this. It's the large, or we call it the big circle, and we're taking away the small circle. And that's actually going to give us what we want in the first place, because that's going to leave us this big circle. Take away the small circle is going to be the area of the ring right here. So let's go ahead and actually take this step by step and see how we can write this mathematically. So the area of a circle is pi, which they want 3.14, times the radius. Remember, the radius of the big circle is 17 squared to the power of 2. All right, make sure you do all of that as one thing. So I'm going to put in parentheses for us to remember that. And then subtract the small circle. The small circle, it's still a circle, so we use the same equation, pi r squared, but it's a different r, it's a different radius. The radius is 12. So we're doing 3.14 times 12 to the power of 2. So this is pi r squared of the big circle and pi r squared of the small circle. So let's go ahead and simplify those two things. Maybe I'll just pull up a calculator on here so you can see how I do it. There's a dashboard. Should have better on my Mac. Let's see. So we're doing 3.14 times 17 to the power of 2. 3.14 times 17 to the power of 2, right? It's going to give us 907.46. 907.46 minus, and this is 3.14 times 12 to the second power. So 12 squared is 144. 3.14 times 12 to the power of 2. 452.16, and make sure that you're doing the 12 squared first, then multiplying by the 3.14 in case you're using a scientific calculator. So 452.16. 452.16, and when we subtract this, well, let's see, take away 2 minus 950, that's going to be 0.30 at the end, and this is going to be 455. You can do this in a calculator, or you can just subtract. And since we're talking about area here, remember area is always squarea. It's always to the power of 2. So this would be 455.3 feet squared. And as you can see here, since we have 0.3, we can round this. We don't need the 0, right? This is equal to 455.3. So if you have a 0 after the decimal point at the very end, you don't need it. You can just leave it like this. I hope this helps understand how we do area problems when you have two concentric circles. Thanks for listening.